Thank you for joining us tonight. We have a really great presentation for you. My name is Whitney Guilford, Media Manager for the Communications Team of the NCNW, and I'm here to provide any technical assistance and to go over a few housekeeping announcements. As with all of our webinars, this will be recorded and posted on the NCNW Headquarters YouTube channel. If you have a question, please be mindful of the time, make your questions brief, and place them in the Q&A section of your drop-down menu.
I'll meet you upstairs.
As there will be one or two similar questions, we will consolidate them to get the best and most effective answer. This town hall will be presented every 2 weeks with an expert in the medical or healthcare field. Additionally, we ask you to join us for our next webinar in 2 weeks on influenza. The flyer for that will go out shortly. At this point, I will turn it over to our co-chair of the NCNW Health Equity Committee, Ms. Shaw. I am so sorry. Ms.
Okay. No problem. Thank you so much. Good evening, everyone. I am Shara Denton, the chair of the Health Equity Committee for the National Council of Negro Women, and I am so honored to introduce tonight's keynote speaker, who's going to talk to us about influenza and answer your questions as we go through the program. Dr. John Lenitzky has a PhD in microbiology, and after graduation with a BS degree, he worked as a clinical microbiology technician, say that 10 times fast, and attained 2 professional certifications. For both certifications, his specialty areas were in bacteriology and mycology. He's laughing because I probably said it wrong. But thereafter, he worked with Staphylococcus aureus for his MS degree and had planned on pursuing a PhD in biochemical physics. Instead, he studied transcription regulation by transcription factor SP1 in a macaque polymerase model for his PhD work. Prior to joining the University of Florida, he was an assistant professor of pathology at the Loyola Medical Center in Illinois. He then worked in industry where he engaged in biodefense-related work, aerobiology related to inhalation exposure studies and small animal models, and various projects with avian influenza, H5N1, and influenza viruses, and the production of biodiesel from algae. Dr. Lenitzky's current research focus areas are UF, aerobiology, virus discovery, virus surveillance with emphasis on anthropod-borne viruses, and influenza virus studies. Please welcome our speaker for the evening, Dr. Lenitzky. Thank you so much for joining us.
Well, thank you very much for inviting me. I'm honored to be here. And I don't see the slides. There. So what you're looking at here is an artist's and computer-generated model of influenza virus. So if I could have the next slide, please. Just to let you know, my virus works with many different areas of influenza virus. One of the things I'm going to tell you tonight is there are many different influenza viruses. Influenza is not just one disease, like a lot of people think. And if you look at the upper right, you can see people wearing what looks like spacesuits. So we have some high containment laboratories where we do work with some of the more dangerous organisms. Next slide, please. So I work in public health, and you know, it's striking to me. This was from the CDC a few years ago. Racial and ethnic disparities in severe flu outcomes. And, you know, Americans don't understand this very well, but it's true. I know that from experience, you know, listening to my colleagues, listening to the doctors, the physicians who are with us. And because we have study sites overseas, like in Haiti, a lot of places, we do a lot of work in Africa. And you know what? What happens here doesn't necessarily happen there. Why is that? Next slide, please. If you look at this particular slide where I have that arrow, one thing that's striking is it says, this is from the CDC, that there are lower vaccination rates and poorer access to health care and distrust of physicians and the government due to historical discrimination. This is real, and this is very serious. It's serious because here in the United States, the net effect of this is there are particular groups that suffer disproportionately from influenza. I'll leave that very complicated discussion for after my talk, because to really understand the situation from a public health perspective, let's look at the next slide, please. There are three things that we really should get a hold of. One is we have to understand the illness. What the heck's influenza? Number two, we have to understand the viruses, because there's more than one type of influenza virus. And the severity of the disease can vary according to the type of influenza. So it's not just one disease, it's not just one type of virus. And we have to understand that. And the last thing is we have to understand something about the vaccine, okay? These are really complicated things. So let's go to the next slide, please. Now, what the heck's influenza? It's an infectious disease, meaning you can spread it to somebody, right? And a lot of people don't know or understand the significance of influenza versus a common cold, that sort of thing. But it's one of the most important emerging and re-emerging infectious diseases. And it causes high morbidity, a lot of sickness and mortality. Yes, every year, lots of people die of influenza. And that's true worldwide. So let's go to the next slide, please. To understand viruses, we have to we have to understand what these organisms, microorganisms that cause illness are. So people like to use the term germs, and there are four common germs: bacteria, fungi, protozoa, and viruses. Viruses are very different from the others. So what's true for the others aren't necessarily true for viruses. Next slide, please. So what's a virus? If you open the textbook, you see all these nice pictures. And these are all artist conceptions of viruses. And they'll tell you it's an obligate intracellular parasite. Unlike bacteria, viruses can only replicate inside a cell, one of your cells, okay? And we like to think of them as simple with a protein code and that sort of thing. But next slide, please. It turns out in real life, things are a lot more complicated. So when you see all those artists' depiction of viruses, what you're really seeing are artists' depiction of what's called the virion. It's the infectious particle that gets into you. But once it gets into you, it looks nothing like the thing on the left, right? It gets into the cell. Oftentimes, it breaks open, releases the nucleic acid inside, and its whole purpose is to take over the cell. It changes the machinery inside the cell to make copies of itself. That's its whole function. Get into your cell, make copies, okay? And so that means a virus is a microorganism that exists in two phases. the particle on the left, that's what infects you, and then what happens inside you. And I have an analogy for that. Let's go to the next slide. It's sort of like a plant. The particles are like the seeds. And then if you go to the right side, that's what's happening inside you, right? So it takes a shift in how we think about these things. Now, the next slide, please. It's very important to realize that the influenza is caused by different influenza viruses. It's not one disease. So people like to generalize because it makes it easier. You know, they'll say influenza is, and influenza does, and it's nothing like that. It's much more complicated. And the outcomes of disease differ according to what kind of influenza virus is in you, the strain, the species, that sort of thing. Next slide, please. And influenza is very important because outbreaks occur every year and many people die. And it's very costly to deal with influenza patients, right? The hospital bills are high. You have to take time off from work. You know, you have to think about the caregivers. It's very costly. Next slide, please. So, to give you an idea, right before the COVID outbreak, this is what the CDC said. The 2018 flu season killed the most people since the 1970s. Well, so up until right before the COVID outbreak, you can see that there was a serious illness that was affecting and killing a lot of people. Next slide, please. So what happens when you get influenza? Remember, there are different versions of this. Well, you might have fever, chills, cough, red eyes, nasal congestion, sore throat. So there are many things that can happen. And depending on the type of virus you get, you might actually also get vomiting, abdominal pain, diarrhea. There's no one set of things that happens in anybody or everybody. And it's not a common, there's no common set of rules, okay? So it makes it challenging to really diagnose. And I'll tell you a secret. If you think you have the flu, try to move your eyes left to right. Oftentimes, your eye muscles are affected. So if you're feeling the symptoms and you try to go, look left to right quickly, it'll actually hurt your eyes. That's something a lot of physicians nowadays have forgotten. I don't know why. Next slide, please. So I told you there are different influenza viruses. There are different species, influenza A, B, C, and D. In humans, at least in the United States, we only worry about A and B. But if you're in Japan, they also test for influenza virus C. And influenza D is something that's just recently been discovered. And it's a virus that was first discovered in farmed animals like cattle. So cattle, what we call cattlemen, oftentimes get infected by influenza D, but no one knew what the heck it was. All right, next slide, please. To understand what species are, so I said they're A, B, C, D. If you look at these pictures, you can tell they're all what we call canids, but they're not the same, right? They have similar properties, but they're not the same animal, right? So a wolf is not a fox, a jackal, but you can look at them And you can tell they're canids, sort of like influenza viruses with the A, B, C, D. Next slide, please. So if you look at textbooks and try to understand influenza virus, they have all these artist depictions, and we don't always know how to use that information. We think anything you read in the textbook, like in the web, is correct. And, you know, they help with our understanding of the virus, but it's not really like that, okay? So you go to the next page, next slide. What we see is that in real life, the viruses aren't really round. Oftentimes they're rod-shaped or like filaments. Sometimes they're oval-shaped. And if you look at the lower right, you'll see they're misshapen. Those are called pleomorphic. And one reason for that is, again, there are many different influenza viruses. Okay, so it's not just one thing. And so what I'm telling you now is you'll read textbooks, especially medical textbooks, and they use terms like, they'll tell you influenza virus is. Well, it's more complex than that. Okay, there are different viruses, their biological properties differ, that sort of thing. Their natural biology differs a little bit. And next slide, please. I won't spend time on this one, but I told you they were filamentous. Even when you look at them and you look at the internal structures, it's nothing like what's actually depicted in books. Because in books, those are models to help us understand things. And in public health, we always remind people, all models are wrong, but some are useful, okay? So let's go to the next slide and talk about types and subtypes. So we have influenza A, B, C, D. Those are types. The ones that we care about most in the US are type A and B. But within those types, there are subtypes, and that's where the complications start coming up. And they're based on two proteins that are on the outside of the virus, the H protein and the N protein, hemagglutinin and neuraminidase. And there are different combinations of these proteins that can be on the outside. And based on those proteins, we have a way of calling the viruses. For example, H1N1, that has H type 1 and N type 1, that sort of thing. Influenza B viruses are not divided into subtypes, but they're two genetically different versions. There's the Yamagata version and the Victoria version. Next slide, please. So in humans, the common influenza viruses that affect us, I said common because others can affect us, are what we call H1N1, that was the pandemic 2009 virus, H3N2, and then two different Bs, Victoria and Yamagata. Now, where the heck do these viruses come from? It turns out a lot of the type A viruses are actually bird viruses. Next slide, please. So what you'll see here, you'll see at the very center is some type of waterfowl, and that can spread the virus to pigs, humans, you know, chickens. For chickens, it's going to go to humans, to cats. So it's not just the human virus. Even some of them even affect birds. Bats. So why do people primarily get the flu during winter? It's because the birds that carry the virus start migrating to where it's warmer, right? And as they migrate, they start bringing their viruses to the warmer parts of the world. I'll point out the University of Florida is a big university, international university. So if you read the textbooks, they'll tell you influenza doesn't happen during the summer. But the first time I came to University of Florida, at the hottest part of the summer, most humid, when the textbooks tell you no influenza, The hospital, University Hospital, was full of patients who had it. Why? Because we have a lot of tourists from the Southern Hemisphere. Their weather's the opposite of ours. When it's summer here, it's winter there, and vice versa. So when summer here, and you have tourists, especially from places like Brazil, they like to go to Orlando, to Disney World. They come in, they bring their viruses with them, and it's very hot here, so they like to go into crowded, air-conditioned, rooms, and they pass those viruses around. And sure enough, when I can trace where the virus comes from genetically, right? So oftentimes we can tell it's coming from the Southern Hemisphere. Next slide, please. So I told you there were two proteins on the outside of the virus, the H and the N protein, that are very important in naming the viruses. But it turns out your antibodies are mostly made against those proteins. They're what we call neutralize the virus. Next slide, please. So with influenza viruses, we have to get vaccines every year because these viruses mutate very quickly. So there's something called drift, where the virus changes a little bit, but your antibodies made to the previous version don't work as well. And that's where you get your seasonal yearly influenza virus. If you have a very big mutation, on the other hand, you can get pandemic flu because they're big changes in the virus. So let's go to the next slide, please. And I use the term strain. A strain, the analogy I use is this. If you look at dogs, they all come from wolves, right? But there are different kinds of dogs. You would probably want to be bitten by a Chihuahua instead, of course, by a wolf or one of these other big dogs. And it's the same with influenza viruses. The viruses change every year, and some of the strains are more dangerous than other strains. Next slide, please. It turns out a lot of these viruses also can mix and match their genes to give rise to new versions of the virus. So what happens typically is big pig farms are where all this happens. It turns out pig protein was the most important thing for human populations to increase. So there are very big pig farms in China, but also here in the US. And oftentimes what happens is birds come into contact with pigs, give them their influenza virus. Humans give their virus to the pigs. And then some mixing and matching happens, and then you get a new strain that either the humans or the birds then pick up and spread elsewhere. Next slide. We worry. So here, if you just look at the colors, it shows you how the virus genes inside the particles, green, and red, they can mix and match, and that creates new viruses. Now, there's one from birds that's very bad. Everybody is complaining about eggs being very expensive now, chickens. And what happened was a very dangerous virus called H5N1, highly pathogenic avian influenza, infected or flocked. Those strains can be very dangerous in humans. So next slide, please. So these are H5N1s. They can cause problems in poultry. And I used to work with some that were way more dangerous than SARS coronavirus 2, right? Some of the strains I worked with would kill 60% of the people they infected, whereas SARS coronavirus, it used to kill about 1%. The new strains have lowered virulence, so that's not the case. So next slide. And what happened with H5N1 is, again, it was something that migratory birds gave to domestic birds, went to humans. Next slide. Why do humans get it from these birds? It's because of our poultry industry. So next slide. And also because humans do peculiar things. So fighting cocks are very important in some parts of Asia, right? And people have these animals, treat them like family members, because if you have a prize rooster, that gives you a lot of money. And people blow smoke into them to make them relax. And I used to live in Asia, and I would see people they'd open their mouth and blow smoke while they put a rooster's beak in their mouth. So it gives you an idea how some of these things get spread. Next slide, please. And here you see we have wild birds that can bring into pigs, right? Because they're in close proximity. So this can happen. So we have H5N1. Next slide, please. Other bird viruses that are of high concern are some of these other ones, H1N2, H7N2. So the point is there are a lot of other influenza viruses. We hope these don't become seasonal viruses, because some of these cause very severe infections. All right. So next slide, please. And what I'll show you here is there are so many different versions of influenza virus, and you'll see the animals they affect. Yeah, they'll affect dolphins, the whales, seals, cattle, horses, and you name it. And so we take influenza very seriously because a lot of these unusual types cause very serious infections in humans. So if you get influenza, what do you do about it? Next slide, please. Luckily, we have antiviral treatments, and the one called Tamiflu, for example, works pretty well most of the time. So it's very good. You have to take it at an early time, usually, within 24 hours after you feel your symptoms, or else it's not going to work because your body gets overwhelmed by the virus. But it's a miracle drug. I can tell you from my wife and daughter when they get the flu, we do a quick test, give them the drug, and they bounce back like this. Otherwise, you can be down for the count for 1 week. You're in bed, you're feeling very bad. And influenza, at least the ones that affect us now, are something else, right? You're feeling fine. 30 minutes later, you feel like, bam, a truck hits you, and boy, you're down for the count, right? You know when it's the flu. It's not just like a typical common cold. So we do have treatments, but the best thing to do is to get vaccines. The vaccines are not always perfect. So let's look at the next slide. And I just listed, there are a few vaccines that you can get. And when you get the vaccine, it's like for COVID, it doesn't keep you from getting the virus replicating in you. In fact, you can get vaccinated and the virus replicates in the upper part and you can still spread it. The vaccine is designed to keep you from getting pneumonia. Okay, very important.
That's just you're looking at.
Next slide.
He was still moving. That's just on.
So you can see when you get vaccines, you're typically given a choice of quadrivalent, which is better than a trivalent. The quadrivalent has 2 influenza A's and 2 influenza B viruses. That's more protective than the trivalent. They differ whether you live in the northern or southern hemisphere. Typically, what happens in the southern hemisphere, the viruses from the southern hemisphere are what they first show up there, and then that's what causes outbreak in the northern hemisphere. So the vaccines are somewhat different. Next slide, please. So how are flu virus vaccines made? It's a very high-tech thing. A lot of the ones you take where you get injected, the vaccines are made in embryonated eggs. But that's not the only way the vaccines are made. Next slide, you'll see that there are different versions of the vaccines that are available now. And they include some that are inhaled, usually the inhaled vaccines are only good for young people. Past the age of 20, they're questionable, okay? And there are complicated reasons for that. But there are different vaccines. The point is, if you can get the vaccine, it's worth it, because otherwise, you know, it can really hit you hard. Now, how's the flu transmitted? Next slide, please. Remember when COVID first started, you heard all this nonsense where you have to wash your hands, right? And we did all this, what we call hygiene theater. You bought things from the grocery, you left them in the corner. None of that really mattered. What really mattered was social distancing, wearing a face mask, right, and staying away from sick people. When we did that, the striking thing at the University of Florida hospital systems is from in 2020 and 2021, there were hardly any influenza virus cases. They just disappeared. Instead of having 200 per day, they were seeing 2 to 3 cases per week. Why? Because when you wear face masks, you clean your hands, but face masks and social distance, it really cuts down on the flu. And remember that, because part of the disparity in some groups is that the housing is not very good. People live in very crowded housing, and there's no good way of separating, the sick people from the ones who aren't sick. And that's a major reason the caseloads can be higher, okay? And if people don't have access to good medical care, that's a real problem. We'll look at the very last slide, and I'll end on this. So, there are many ways the virus can be spread, right? Airborne transmission is very, very important. Now, is it possible to get the virus if you touch something? Yeah, but to tell you the truth, not too many people will go on a surface like this when you're outside, then take your hand and stick it up your nose, okay, that's not the way it's typically spread. However, with H5N1, there are other ways that people acquire it. And here's something interesting. This is a soup that's made with raw duck blood. You know that waterfowl can be big carriers of influenza viruses, right? And people have caught the virus from ingesting raw duck blood. So my point here is we use common sense, right? Probably, maybe raw duck blood's an acquired taste, but given a chance, it's probably not the best choice, right? So we can control the extent that we get infected by our behaviors, and hopefully get a vaccine. It's important to get a vaccine yearly because the viruses mutate, and it's important to have at least some level of protection so that if you get sick, you're only feeling a little off for maybe half an afternoon or something like that, but you won't be hospitalized, okay? Very important. I'll leave it at that. And now we have to understand, if we know what the disease is, how a concept of the virus is, and understand that vaccines can help, now's the time to really figure out the more complex issue, which is, why is there so much disparity in the healthcare system here in the US? Why are certain groups more likely to be hospitalized with influenza? Okay, it really doesn't make sense. There's nothing biologically different. It's really, you know, we have to get a hand on the social issues and other issues that contribute to that. Okay, thank you. I'll leave it at that.
Wow. First of all, Dr. Lipnitsky, thank you so much for that outstanding presentation. I have learned so much. I know that the members have learned so much. I have been grossed out enough to never eat chicken. But I wanted to open the floor to questions from our members, and also members tonight. We're gonna play a little game. I'm gonna ask you some questions, and we're gonna see how much we collectively learned from Dr. Lednitsky's amazing presentation. But let's start with questions from the audience first. We have one. What is the relationship to COVID and influenza?
Well, the viruses that cause them are totally different. And, you know, you're asking a very, it's not as simple, it's a very profound question, because in COVID, you can get a systemic infection. Now, people lose their sense of smell, you know, it gets in the brain, it gets into the organ systems, so it could get in the heart, the liver, etc. Most influenza viruses don't do that. The H5N1s can do that, okay? So in general, the outcomes are not quite the same. They both start as respiratory infections. But you'll notice that with seasonal influenza viruses, about up to 80,000 people a year in the US can die of it. But with COVID, it was much greater. Now, the thing with COVID is most of the people who died were people 65 years and older. Okay? That's something that a lot of people don't quite didn't understand. They also typically had some underlying health conditions. The people who have severe influenza also tend to have underlying health conditions. Diabetes is one, and that sort of thing. So with the old strains of virus that caused COVID, the outcomes were really severe. With the new Omicron strains, it's not really as bad. But again, we have to be careful to generalize, because H5N1, like I say, it killed about 60% of the people it affected. The thing is, it wasn't easy to transmit person to person, right? If the virus, you can imagine if a virus like that transmits easily, that would be a major disaster worldwide, right? So we can control those diseases now. So for both COVID and influenza, we have antiviral drugs. You know, they can be used for treatment. So now they're both manageable diseases. But if you can prevent them, that's the best thing. So vaccines really help.
That was an excellent question and a thorough answer that has all my brain synapses firing. So our next question is, how effective are the mask and social distancing with COVID versus influenza?
Well, another profound question. I mean, that's a very complicated question. So you remember when we first started wearing masks, the nonsense that came out, oh, you just make cloth masks. And if you went to the web, there were all these things that looked like mosquito netting, but they were fashionable that people were buying. And that's because most people, including health professionals, have no idea how a face mask works. And we have different types of face masks, like the N95, the surgical masks, and lesser masks, right? So when you wear the masks properly, meaning they fit your face, and you don't reuse them, and you know how to put them on, you don't do things like, you know, stick your fingers like this as you're taking out the mask, like a lot of people do. The masks work fantastically well. They'll really reduce your chances of acquiring the virus. They're especially important, though, if you're sick and you wear the mask, it helps other people not get sick. So there's a lot more to the mask than meets the eye. The outer layer is very different from the inner layer. The inner layer is made to absorb moisture. The outer layer is made to repel moisture. But the magic layer in a lot of this is the inside layer, because it's what's called an electret. If you have a good N95 mask, right? An electret is something that has a static charge. And so should the virus particles penetrate the outer or inner one, the static charge in the electret traps the virus and does it very well. The key is you can't use the mask for a prolonged period of times because moisture and heat are the enemies, and that charged inner surface loses its ability to bind the virus, okay? And if you read the web, it's all over the place. And, you know, you have all these experts who yak. And I guarantee you, most of them have absolutely no idea what they're talking about. Be very careful what you read. But it's like I say, if you look at the University of Florida, 2020, 2021, there was no influenza, but no RSV, no rhinovirus, no adenovirus. All the airborne respiratory virus infection viruses were contained and controlled because we had masks and people were doing social distancing. Okay, so the masks do work. So as they're used properly and you have a good quality mask, don't buy those things that look like mosquito nets, you know, and stuff. You know, we did a lot of things that really didn't work. Remember all those acrylic barriers that were putting in offices? Don't do anything, right? Because the virus current in the air just goes over them and goes down. The only thing they're good for is if you're in a bank and someone's talking to you, their spit gets trapped in that acrylic. So you have to know what's effective and how to use it properly. But face masks are, if you have quality face masks and you know how to use them, they're very good.
All right, ladies, I hope you heard that. He said you can't use masks for long periods of time, so make sure you're regularly changing those out. We have a couple more questions. You talked about the birds and pigs being carriers of influenza. How does the FDA track if there's an outbreak of influenza in these food products?
The FDA, that's not really their purview. And if you're eating pork or something, you know, you're going to cook it. You're not going to get influenza. it's not going to be in the tissues unless it's one of those very strange strains. What happens in the pig farms, though, is the humans and the pigs exchange the virus. And here at the University of Florida, we actually did some studies. One of the guys who graduated in my lab did some very interesting studies in China. And he brought my aerosol technology there. And they showed that on these pig farms, the pigs and the humans were passing the virus back and forth. The pigs were getting some seasonal human viruses. The humans were getting, right? So that's the more important one. Cooking the food, if there's a virus in the meat, cooking it gets rid of it. So it's not really the FDA necessarily that keeps an eye on that. It's really the CDC and possibly the NIH and the USDA, the United States Department of Agriculture. Very important.
Right, so we have at least 3 agencies that do track viruses, and that is excellent information. We have one more question, it looks like. What is the current data with the mixing of persons who have not been vaccinated versus those who have gotten vaccinated? There seems to be no increase in COVID cases of those who have not been vaccinated and do not wear a mask. That is an interesting question, I will say that.
Yeah, you have to be extremely very careful because there's so much misinformation on the web. And keep in mind that a lot of government agencies aren't even tracking COVID anymore. So I'll bring this up. At the University of Florida, we vaccinated not only people on campus, but also a lot of the people in Gainesville. I think they vaccinated over 100,000 people. Our campus has 54,000 students, 34,000 staff, right? And unlike what was happening at the beginning of the outbreak, where a lot of people were dying, it's gotten to the point where so many people were vaccinated here, I think, that they're not even keeping statistics in COVID anymore. And the new strains are very mild. I think what happened was as people started getting vaccinated and revaccinated or got natural infections with the virus and built up immunity, that it became less virulent. I mean, people weren't getting as sick, right? And plus the new viruses are less virulent. Now, the vaccines that are available right now are not very good against, they're not as effective against the new virus strains as the former vaccines, but they will still keep you from being hospitalized. That's the difference. So I said, for example, where I work, one of the women here got COVID for the 3rd time just a few weeks ago. 2 weeks prior to that, she had very mild sniffles. And I was shocked that she came to work, and her tests, her antigen tests were negative until a few days later when they became blaring hot. And then she got cleared, came back to work, wasn't feeling well again, and had COVID again. And once again, it was a 1-day thing. She had been vaccinated though. And so this is what we see. I'm just not hearing of deaths right now. And it's gotten to the point where, people have gotten very nonchalant. They say, it's just another mild virus now. I think the key was that the vaccines helped people fight off the virus. And the ones who are dying inevitably were those who weren't vaccinated. Lots and lots of people refused to be vaccinated. Remember when people were taking ivermectin, for example? Well, there were a lot of lots of people who are in agriculture, and all these macho men. Oh, I'm not afraid of a little, and then they'd be hospitalized with severe COVID, even though they were taking ivermectin. So in the long run, really what's been helpful are the vaccines. And then we have Paxlovid now, which is helpful, right? And so it's worth getting the vaccine. It's not going to work as well against the new strains as the former ones, but it's like influenza, right? Every year now, because the virus mutates, you have to get the updated vaccine. And I have a feeling that, that's going to be something we're going to live with now, getting updated vaccines. But again, bear in mind, the new strains of the virus are causing milder infections, right? So it's still very important to consider getting vaccines, and don't listen. The web is so full of misinformation. It's amazing. Me as a virologist, every day, I was getting bombarded. The height of the COVID thing, people knew I worked with the virus. I was getting 25, 30,000 emails a day. And it's people telling me the most inane things. So for example, in Southeast Asia, a lot of hospitals stockpiled coconut oil and coconut juice because somebody said, oh, the oils, the fatty acids in coconut kill the virus. Well, not a single patient improved by drinking coconut juice. And then they were telling people, rub it on your skin and then gargle with it. Well, that's not really going to be very helpful, right? And that was the type of misinformation. What about eating sweet potatoes? That didn't help anybody. Somebody started this thing, if you get a potato, cut it in half and put it beside you, that it will attract viruses from the air and they'll protect you. So when COVID first started and everyone was Zooming, I was surprised how many people believed that, because they'd have potatoes right by the screen. And it got to the point where somebody here in Gainesville was selling earring things where you could cut chunks of potato and put them here, and they said, that's going to protect you, right? So, use your common sense and realize that there's a lot of total misinformation out there. And if you try to, find the true sources of information, you'll do a better job of protecting yourself.
And that is why we do this, so we can get the truthful information out there. So thank you so much for so thoroughly answering that question. All right, friends, we got about 4 minutes left. So we're gonna play a little game. I want you to put your answers in the chat to these questions. And then Dr. Lednitsky can tell you if you're right. Our first question, there True or false? There are 2 relevant species of influenza. True or false? Okay, looks like I've got some trues. All right, Dr. Lednitsky, what do you say?
Yes and no. So 2 that are very important, A and B in humans, but there are actually 4 species, C and D. So A, B, C, D are the 4 species. So alpha, beta, gamma, delta influenza virus.
All right, so there are 2 that affect humans the most, but there are 4 species total,
Yes.
correct? Okay.
Correct.
All right, friends, next one. True or false? If you think you might have the flu, try to move your nose left or right. Let's see. A couple falses, couple trues. Oh, mainly falses. What do you say, Dr. Lednitsky?
Yeah, that's false. So remember, it's eye muscles. So try to give furtive glances, right? If it hurts, chances are it's probably the flu.
So it is your eyes that you move and not your nose. Apologies for the trick question, friends. I think we got time for maybe 2 or 3 more. Let's see. So, okay, this one's going to be a little tricky. There are 4 FDA-approved antiviral medications for the flu. Can you name one of them? That is extremely tricky. You know what? I'm going to throw that one out because these actually have some. Oh, no, we got an answer. Okay, so the answer that we have is Tamiflu. Is that correct? Thumbs
Correct.
up.
Very good.
Very good, guys. Very good. And let's see. Let's do one more. True or false? Bird migrations affect the way that humans contract the flu. True or false? All right. Looks like there's a consensus that that's true. Is that true, Dr. Lednitsky?
Absolutely. It is true.
Absolutely. Friends, thank you so much for joining us tonight. I would like to send all of my gratitude and respect to Dr. Lednitsky. We very rarely approach the flu topic from the virology aspect, where we have an expert to break down how the virus actually works and how it affects us. And I am so grateful for this opportunity to hear from you. And I know that everyone in this audience has been so engaged and has learned so much tonight. Looks like Miss Shara Denton is not, had to drop off. So I'm going to close us out. Thank you so much for joining us for this NCNW influenza webinar. You guys know at this point, we do these every 2 weeks. We find experts like the amazing Dr. Lednitsky to dispel some myths, to drop some truth bombs, to really get that information out there that we need to keep ourselves safe and the other people that we love. On that note, I'm going to bid everyone a wonderful evening, and I hope everyone really appreciated the amount of information and expertise that we had the privilege to witness tonight. Good night, everyone.
Good night.